right, so some misconceptions that I'll throw out some thoughts on geothermal is that actually it's not geothermal. It's actually a ground source heat pump is the technical term. And geothermal was a really easy way back in the late 80s, early 90s to market to. And it kind of just stuck since, and it's been to the benefit of the consumer to easily understand. It has a trigger word for what the technology is and something easy to remember. So when you're comparing geothermal to when you're comparing geothermal to air source heat pumps, it's just there's air source and there's ground source, and that's basically the terminology difference. But on this slide, it just shows that the Earth is actually a solar battery, if you will, or a thermal battery itself. So on this next slide, it's a little bit more in depth, but really the main point about geothermal is that of the sun's solar energy, solar thermal energy that's hitting the Earth, we're absorbing 50% of that into the ground. And that's the renewable part that we all need to tap into to take advantage of versus using those fossil fuels. So in the winter, we're using that solar energy that was put into the ground. We're tapping into that basically, and we're extracting that heat out of the ground, and we're going to bring it back up into the home or to the building to help the equipment do basically half the work, if not even more. So we're bringing the loop temperature of the ground up to the building. In the summer, we work the opposite, and very much so like a refrigerator. So we're going to take the energy, the hot energy out of the house in the air conditioning mode, and we're going to dump that into the ground. So in the summer, like where we're at here in Illinois, we'll get up to 95, well over 100 some days, and that's where geothermal systems at the extremes really pay for themselves, because we're able to take that hot energy out of the house or the building, and we're going to dump that down into the ground, which is about 55 degrees here, and we're not trying to dump hot energy into a hot environment. And that's where we really capitalize on a system of efficiencies. So different types of ground loops. What actually we're dumping down in the ground are high-density foam material, plastic material that the construction of the pipe is. And there's multiple ways to do it, but our approach is get however you can, get it in the ground. It doesn't matter what the best way is. It's just how can we do it in an economical way that's best for our consumer. Horizontal systems here in our top left are generally almost the most popular now, and they're the cheapest to install. If somebody's got land mass to do so, a few acres, they're perfect to do. For example, I think some people have always asked me, well, what's the best one? It doesn't matter. As long as they are installed properly and they are sized adequately, that's what is number one. With a loop, though, you can always oversize the loop a little bit. There's an extreme on that, but our kind of rule of thumb is make a fat loop, we call it. So if your system needs a 3-ton system, heating cooling system, well, then we'll put on a 4-ton on there just to be safe and make the system run even more efficiently. But I think I can now, it took me a while, but I think I can now answer somebody's question, though, on what's the most efficient and what's the ideal situation. I truly believe that that's a horizontal system that's got a spring running across it. So if it's one that's in the ground, about 6 feet down on average, and that would be where there's a spring coming out of the ground naturally and running across the loop itself. So I got lucky on that myself, actually. a few months ago digging my own personal loop, and we hit one. And so many of our half of the loops are actually in spring water, and it's a constant 55-degree temperature, making that loop perform at a great level.
Kyle, does that have any issue with polluting or degrading the groundwater?
None. Thanks. Great question, because it's a closed system. Now we do put a mixture of antifreeze into the loop itself. That would be water and either methanol or glycol, and we use that antifreeze to get us down to a certain freeze protection level. But it is a very closed loop system with fusion points where the system will not leak. And on top of those fusion joints, before we ever bury the system back, we actually do a pressure test and make sure that we will never have any leaks. And that way the system is basically foolproof, and the only way you're going to have issues is if you were to hit it with and sometimes it happens. Farmers, for example, they'll put their loop out in a cornfield behind the house, and then they wanted to come in and field tile that, and they hit it on accident or whatever it might be. So once they're tested and put back in the ground, though, there is no problems to be had. And the warranty on the loop itself is about 50 years, I believe now, and but it's expected to last forever. There's other types of geothermal systems out there that are available too, where you can put copper in the ground, but the thought on that is that it could be corroded over time.
Is there more to that? Sorry.
No, and the last one would be an open loop, and this one, in my opinion, I'm not a huge fan of. It's a very economical approach, but it's very efficient because you get a constant, let's call it 55-degree temperature coming into the heat exchanger of the unit itself. However, when you have raw well water coming into a system, you would constantly be having the elements of the localized water there coming into the heat exchanger of the product, the unit itself. Therefore, over time, has a high potential to break down the system from calcium buildup or acidic water that could break down the metals actually inside the heat exchanger itself.
Great, thanks. And while we're on the conversation of loops, could you speak even briefly to the idea of, let's say these eco developments where they do shared fields, what that looks like, and then also is there any risk of depleting I guess the temperature of the earth if there were a lot of geo loops in one area?
Oh, yeah, I'll take that second one first, actually. I've got a funny story on that one. So, the northern lakes of Idaho are, I believe, to be thousands of feet deep. And it was believed that if there was too many geothermal loops in the lake, that it would affect the temperature of the lake and it would affect the fish. And that is so crazy because there is not nearly enough loop in the actual water to affect anything. And so we do size them accordingly on pond loops, for example, to where our kind of rule of thumb is on an average home, you need at least 15 feet deep, and of that 15 feet deep, about a half acre of that 15 feet deep. But so we don't have any issues there. Now, on the community side, what a great question, and it's something we don't tap into very often, but there are communities popping up for net zero all over the country. I believe there's one in Louisville, there's one in Austin, two in Atlanta now, Tri-Cities in Washington, and then there's many others throughout the years in the past. But you could do very cool systems, and even if you were a developer, you could actually turn yourself into a utility as well by doing a community loop installation and then having that homeowner pay you to, I don't know, $20 a month or something they would tap in to have their geothermal system, they'd have access to their geothermal loop. And at that point, they would have a large centralized system, and it would be a very easy way and a very attractive centralized loop for a development. So there's multiple ways to do it. You could do it in the fashion where it'd be community, or you could do it where just geothermal is required in the subdivision for the features and benefits, and then each home could have their own individual loops. So it just really depends, but sizing of the system up front is always something to consider, whether are the homes going to be all the same size, or are they going to be more on the custom home side and be required to have various sizes of heating and cooling systems within.
So the other question was, wouldn't resulting heat be greater with vertical loops instead of just the 55 degrees?
It's just personal preference, really, and land mass. Think about it this way. Everybody's kind of got a friend or, somebody with a backhoe or trackhoe or whatever it might be. So your cost to install a vertical loop is going to be with fewer supply and demand services. So those are going to be your well drillers. And as long as the loop is deep enough in the ground with a horizontal system, it's going to perform the same way that a vertical system would. But a vertical system is going to be, I guess, let's call it a little bit safer as far as installation goes, so that you would not hit it. You could put it under a driveway, for example. You can, even if you wanted to get ambitious, you could actually do it underneath the basement or a crawl space before the home's actually ever built. But you really, for an average house, you can get a 6-ton vertical loop in a space of about a 10 by 20. So it's all the evaluation of the job itself, of the prospective job, I should say, of what is the most feasible way to get the loop in the ground. Some contractors, though, that's all they'll do. It doesn't matter how much land you have. They'll just do a vertical bore every single time, and then do minimal horizontal trenching. So it really just all depends, but they all perform the same way.